In this video, we're going to look at the angles of polygons. So we're interested in the interior angles of a polygon. This is building off our ideas of interior angles of triangles. So first, let's discuss what a polygon is. A polygon is a closed plane figure made up of three or more line segments that intersect only at their endpoints. What does that mean? Well, it means our shape's going to be consistent or consisting of line segments, so parts of lines that attach or meet at their endpoints. And it can't, so because it's a line segment, it can't curve. So if I have a curve in any kind of figure, it's not a polygon. I also can't have intersections of those line segments, like, for example, them running through each other. So let's look at our shapes here. So these are three examples of polygons. Line segments meeting at their endpoints. No curves, no intersections. If I look at my not polygons or non-polygons, here the blue one is not a polygon because of that curve. The purple one, same thing, it has a curve, so it's not made of just line segments. And then the third one, we have these two line segments that intersect each other right here, which makes this not a polygon. Now, if I took these two parts and separated them, and I had like that triangle and they didn't intersect, these would be two separate polygons. But because it's one shape here, one figure, and we have that intersection, we actually don't have a polygon in its entirety. So we're going to focus on that piece of that not being a polygon. Then with polygons, we have the idea of convex and concave. A polygon is convex, so we're looking at this blue one. It's convex when every line segment connecting any two vertices. So I'm just going to mark my vertices here. I have vertices where my line segments are meeting. So 4 vertices. If I draw a line between any of those vertices, it lies entirely inside the polygon. This is not true for a concave polygon. So looking at our green shape labeled concave, if I take our 4 vertices we have here and I go and connect this vertice to this vertice, you'll note that my line is outside the closed figure. That means the polygon is concave. So it almost has like an indent in between two of the vertices here and here. In our convex polygon, we don't have that indent occurring anywhere. Another important piece to polygons is the idea of a regular polygon. A regular polygon, all the sides are congruent. So sides are congruent, meaning all of the sides are the same length. And all the interior angles are also congruent. So regular, when we say a shape is regular or a polygon is regular, we're implying those two pieces. All the sides are the same, all of the angles are the same, and that's what makes it regular. So for example, I got a couple shapes here: triangle, quadrilateral, pentagon, hexagon, octagon. This is an example of the regular polygon of that figure. So regular triangle. All of the sides are the same length. All of the angles are the same measure. A regular quadrilateral, all of the sides are the same length. All of the angles are the same measure. And that would stay consistent with anything that we determine a regular polygon. So that's special. Now, irregular polygon. Now, we usually don't use the word irregular polygon. We would just say like a triangle. And then if it's a regular triangle, we would specify it as a regular triangle. Here we can see that we have a length that is not the same length, or a side that's not the same length as our other sides. And we can kind of see that throughout here, that the sides are not all the same, the angles are not all the same. So those are just some important vocabulary terms that we want to know. So just to recap, a polygon versus a non-polygon. So some things for non-polygons are curves and intersections. Convex versus concave. Convex means you can connect every vertice going through the figure, and concave means you can connect two of the vertices by going outside of the figure. And then what we just discussed, regular polygons Regular meaning both all sides are the same and angles are the same. So congruent sides and congruent interior angles. Now let's look at those interior angles and a special fact about those interior angles. So we're going to look at what's called the interior angle sum of a polygon. So angle sum meaning addition. So or answer to an addition problem. So this is what the angles would add up to. And we're talking the inside angles or the interior angles. So the sum S of the interior angles of a polygon with n sides. N sides, it's a variable, so whatever number sides it has, that's what we would replace the n with. So for example, in a triangle, n would be 3. For a square, n would be 4 because it has 4 sides. So the sum, what those angles add up to, is going to be equal to n minus 2. So we're going to take the number of sides, and we're going to minus 2 from them. We're going to take that value, and we're going to multiply it by 180. And this will tell us how many degrees the inside angles add up to. Now, angles of a regular polygon, remember we said that a regular polygon, all the angles inside are the same, which means they have to be the same amount, which would imply that we would divide to find that out. Now, not sure if you caught this through our discussions, but the number of sides that a polygon has is equal to the number of angles that a polygon has. So if I'm thinking a triangle has 3 sides, it also has 3 angles. A square has 4 sides, it also has 4 angles. So all the angles of a regular polygon, they're congruent, which tells us we can take our n minus 2 times 180, and we can divide that by the number of sides that we have, because those sides are the same as the angles, so that n can be the same value. So let's take a look at what this would look like in practice. So let's go ahead and example 1. Find the angles of a regular polygon. So we're going to find out what should all of those angles add up to. Looking at our first shape, I want to identify what n would be. So remember, n is the number of sides. So here I have 1, 2, 3, 4, 5 sides. So n is equal to 5. Using my formula that I have at the top here, and maybe I'll just keep it there. So we have n minus 2 times 180. So n minus 2 times 180. I'll replace n with what I have as equal to n, which is 5. So 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is going to give us a sum of 540 degrees. So all 5 of these angles, when I add them together, will equal 540 degrees. Now, if it's a regular polygon, those are all the same. So we said take that value and divide it by what n was. So 5 angles, 540 divided by 5 is equal to 108. So we're stating that all of these angles in here would be 108 degrees. Because it's regular, and that's the only reason we can do that is because it's a regular polygon. They told us it's a regular polygon. B. All right, first we got to find out how many sides I have. Looking at this shape, I have 1, 2, 3, 4, 5, 6, 7, 8. So the value of n is 8. Angle sum, 8 minus 2 times 180 gives us 1,080 degrees. Now, since this is regular, I can divide it by how many angles I have, which would be 1,080 divided by 8 gives me a total of 135 degrees. So every single angle in here, 135 degrees. Why don't you pause the video and try that last one on your own. All right. right, here I have n is equal to 6 sides. 6 minus 2 times 180 gives us 720 degrees. Since it's a regular polygon, we can divide it by 6, giving us a total of 120 degrees for each angle. All right, so why is this useful to know the total sum? Well, it's going to help us in a problem like example 2. Find the missing value of the polygon. All right, so I'm looking at a polygon here. So I see some angle measures. I see one of them is missing. My goal is to find that missing one. Now, in order to find that missing one, I have to know what these all should add up to. And in order to find that, I'm going to use that angle sum idea. So let's go ahead and find out how many sides there are here. If I count carefully, I get 7 sides. So 7 minus 2 times 180 is going to equal 900. All right, so I know all of these sides should add up to 900. So I'm going to go ahead and write down an equation stating that. So it's going to be a long one. X plus, and I'm just going to go around. X plus 128 plus 130 plus 120 plus 115 plus 145 plus 140, and I'm back to where I started, and that's going to equal what that sum gave us, 900. So we're using that formula to help find out what our equation should be equal to. If I take these, the left side of the equation, and I simplify it, I get x plus, add up all these values, 778, bring down my 900, and subtract 778 on both sides. And I get an x value of 122 degrees. All right, let's try this again with part B, or problem B. All right, so I have 1, 2, 3, 4, 5 angles. I got some x's in here I want to solve for. Before I can do anything, I have to find out what these all should add up to. So 1, 2, 3, 4, 5. 5 angles, same as the number of sides, so 5 sides. 5 minus 2 times 180. Notice I'm using this for every problem here. It's 540 degrees. All right, so that's what my equation will add up to. Let's go ahead and add up our equation. So I'm going to kind of simplify this on my own. I'm going to take 2x and 2x. So 2x plus 2x, that gives me 4x. So I'm kind of writing it simplified right away. Then I'm going to go ahead and take my value 110 plus 145 plus 145. And that's going to give me 400. And this is going to equal that value I got before, 540. We're going to subtract 400 on both sides. That leaves us with 4x is equal to 140. Divide by 4. X is equal to 35. Now, I want to be careful here. It's a little different than the last problem. Because my angle is not x, it's 2x, I have to plug in that 35. So this angle here is really 2 times x, which is 35. And that will give me an angle of 70 degrees for the whole measure. And this is what we can do with polygons and their interior angles. Hope this helps.